Hello everyone, welcome back, and today we are going to solve another Leetcode problem, which is the find pivot index. And of course, as usual, we are going to use TDD or test-driven development to solve this kind of problem. So let's go through the problem. So here it is stated that we are getting an array of number of integer and we need to get the pivot index of the array. So what is the pivot index? It states here that if the left side of that index equal to the right side, in the terms of the sum, then that index is the pivot index. So for example, this pivot index is 3, so 0, 1, 2, 3. Why is that? Because on the left side, if we sum it, it's actually 11, I guess, and this one is also 11, so that's why this one is the pivot index. So we just return that index, which is the 3 here. But there are other cases, like for example, if we don't find the pivot index, we need to return -1 here if we don't find the pivot index. But there's also cases like for example, this case. So what is the left side of 2? It's actually no one or no number. You could assume that is 0, and this one is 0 as well, right? 1 plus -1 is 0. So the output is that first index here, because it's on the edge here. So we need to return the leftmost pivot index here. Okay, so I think that's pretty simple. So let's get started and let's go and open the Xcode as always. So let's go with macOS, and I believe we can go with the framework as usual. And let's rename that into the pivot index here. Save it somewhere. Okay, as usual, if we are starting with test-driven development, then we are trying to make sure that everything is okay on the start. So it's better to run the test as we start. So let's run the test, Command U. Okay, we have a green test here, so I think it's good. Great. So the reason why I choose the macOS framework is I don't think we need to, choose the iOS framework. Like iOS project, because if we use iOS project, it means that usually when we test, then we need to put up the iOS simulator by default. So I don't want that putting up slows me down. So that's why I choose the macOS framework or macOS project. So, okay, we are in a good start. So let's delete this and let's start with the failing test as usual. Failing test should be fail, and make sure that we are failing, which is the very first type of test-driven development. All right, so I think we can start to code here. So let's go back and copy here. This is the sample code right there. So okay, since we already bring this template, so why don't we start to code? So let's start with the task pivot index. Let's cover for example, the -1 scenario, because it's the minimum way we can cover, right? Returns -1 on not found nums pivot index here. Okay, test pivot index returns -1 on not found pivot index. So we need the SUT as well, and what is that? The SUT is the solution, and we need to trigger the action, which is the SUT.pivot index, and let's start with the empty, right? And we got the result here, and we need to assert that the result should be -1 right there. So if we this is the setup. If we like to run, and of course the compiler is telling us, hey, we need to return this basically. So let's just return -1 here. Return -1. And yep, so basically we are passing the test. So let's go and commit here. So returns -1 on not found index. Okay, cool. So what else can we do? So I think we need to cover the edge scenario, like for example this one, because this is pretty easy, right? So let's cover this one. Or maybe we need to increase this one first, right? Because let's say this is the empty one, because of course this empty is not found. So maybe we can refactor this one, returns -1 on empty array, right? So let's run this again. Okay, should be empty. And let's rename a test. Okay, so what else? So test pivot index returns -1 on not found item found index here. So test pivot index returns -1 on not found index. So basically we need the setup as well as usual, and we need the result here. But in this case we need some value. Let's copy from here. Okay, and we want the result is actually equal to this one, -1 here, right? So of course it is going to pass. Why? Because we are forcefully returning the -1 here. We are hard-coded it, but that's okay, because in test-driven development we are trying to evolve the code step by step. That's also the part of the test-driven development. That's fine. So let's commit here. Pivot index returns -1 on not found index. Cool. Okay, now we need to cover the other scenario, so that the code, like our code here in the production, will be evolving alongside with the test. So here we have another test cases here. So let's copy, and it should returning 0. So let me put here, and let's create a test case as well. Test pivot index returns 0 on edge pivot index, right? So what we want to do is we need to copy and paste the SUT, and what is this one? We need to copy and modify here, and hopefully we can get the result as 0. And let's of course run the test again, and let's see. Now we are having a failing test. Okay, that's cool. Why? Because we are forcefully returning -1 there. So we need to do some logic around here, right? So how do we handle this? For example, for an empty one here, we can return empty, or return -1 if it is empty, right? So if the nums dot is empty, we just return the -1 there. But if it is not empty, we need to do some calculation. So I'm gonna start with the idea of looping inside a loop. So it's like O of n square, and we are going to gradually move it to the more optimized solution. So the primary goal right now is just to make the test green. So how do we do this? Basically we can scan through the array. For example, we have this array, right? And this array, on every single iteration, we need to count or sum every single value on the left side of that iterated index here. For example, in this first iteration, this one, we need to count the value on the left side here, and also on the right side. And after that, if we get the value, then we need to check whether the left set value and the right side value is the same. If it is the same, then we found it. We need to return the index. Otherwise, we need to return -1. So let's do that. So basically, we want to loop for every single number in nums, but I think we need to get the index. So let's get the index here as well. Enumerate it here, and basically we need to check on every single iteration, right? if the left sum is equal to the right sum, then it means that we need to return that index, right? So if we find this true in this statement, it means that we have the pivot index. And if the loop is finished here, then it means that we don't have, or we didn't found the pivot index, like here. Right, so what is the definition of the left sum? So let's try to calculate the left sum. Calculate left sum before the index of the current index, and the source is from the nums. Okay, right. Okay, that should be it. And how to get the right sum? The right sum is the calculation after the current index based on the source, which is the nums. Okay, I think that should do it. Let's trigger again and let's see. Okay, basically we need to define this function, right? So let's define below here, calculate left sum before index, that returns a value here. So how do I calculate this one on the left sum? So basically we could iterate from for example, for I starting in 0 through the index, right? Because we want to calculate starting from the very beginning through that index, I mean the value before that index. That's why we are using this one. And basically we want to sum up that number. So nums at that I, and basically we need to return the sum here, but we need to define the initial value of the sum, which is 0. Right. Now I believe that should do it here. And okay, this one is the source, or we can call it nums as well here. And now we need to concentrate on this one. So the calculate right sum is actually pretty much the same thing, but it will be counting on the starting from that index to the very end of the nums. So let me do it quick. Okay, so how do I do this? We basically need the looping again for index or for I, and starting not from 0 but from the index plus 1 to the very last index minus 1 here. Basically we need to do the same thing here because we need to accumulate that value and we need to return the sum, and of course we need to define the sum as well. Right. So if we right now run the test, I believe it will cover most of the scenario, but sometimes it will be failing. Okay, it's easily covering the scenario here, but it is failing here. Why? Because it's out of bound basically. So we need to check the out of bound, so we can guard the index plus 1 is hopefully still lower than nums.count. Otherwise we just need to return 0 here. So this is gonna be do the checking, I mean like out of bound checking. So let's run the test again and let's see. Okay, we are passing, that's good. So let's commit here. Pivot index return 0 on edge pivot image. Okay, cool. So let's try to add another case here. Oh, seems like we need to refactor, because in test-driven development, basically after we pass the test on the green state, then it's time to refactor. Now the compiler, our friend, is telling us to refactor this code. So let's run the test again, since we don't use that number. Okay, that's cool. So silent compiler warning. Silent compiler warning. Cool. So let's try to increase the test case here. I'm gonna use this, and hopefully the index output is 3, the pivot index. So let's do that, so that we can just copy here. Returns correct pivot index, and the value is this one. Whoops. And hopefully it should be returning 3 as the pivot index. So let's command you again and let's see. Okay, cool. Seems like we are in a good shape here. So let's try to commit here. Pivot index returns correct pivot index. Cool. Now I'm kind of confident on this one, so I think we can just like copy and paste the result there to the Leetcode. So let's try and copy and paste for there. Okay, I think we can like run the test here and submit if we are good to go. That's cool. So let's submit. Okay, so that's how we can use test-driven development to solve this Leetcode problem. But that's gonna be returning O of n square, which is actually not good. But I think in the next part, I'm going to refactor this one into another more efficient algorithm, so that we can demonstrate how test-driven development is going to picking up this kind of code refactoring strategies. So let's continue on improving this pivot index problem, so that we can get the O of n time instead of O n square. So in this example, we are actually done well pretty much, because we are passing the test without any problem. The Leetcode is okay as well here. But since we are doing these two for loop, for example, we are scanning through the array here, and then we recalculate these two. So basically we are doing the nested for loop, then we can say that we are getting the O of n square time. So the way how we can like improve this is, instead of recalculating this left sum and the right sum, we can focus on previous calculation and then add that number for the left sum, and on the right sum we can get using a certain formula. So let me try to bring some example, maybe this one. So for example here, since we are going to iterate, of course we need to scan through the array here, and while we are trying to, well, in this iteration here we already have the stored left result, right? And if we continue to the next loop, and then we don't need to recalculate from the very beginning, I mean like 2 plus 1 is 3, okay? So instead of recalculating that, we can get the previous value, I mean the previous sum, and add it by this value in here. So in that way we can avoid recalculating using for loop here, right? So it's like more efficient. So how do we get the right sum now? Let me bring a good example here. Okay, in here, so for example, how do I get the right sum? So suppose that we are in the mid of iteration here, and we need to recalculate, I mean like we need to calculate this left and right value, right? So how do I get this? So instead of recalculating every single time here, we can get the total of this one, I mean like the total of the array, and we can subtract it here, which is this one, and so that we can get this one. So how do we like get this one? It's basically the left sum here plus that current iteration index. So that's how we can do that to get the right sum. So I hope that's pretty easy to understand once we get down to the code. So basically we had a test so that we can verify it quickly if we change things. So okay, so again, how we can count the left side of the sum. So instead of recalculating it, we basically can get that current number and assign it into a variable. For example, the left sum here. I mean, like, we can accumulate that, right? So basically we need two things: the left sum, which is initially starting from the 0, and the number is actually this one. Okay, and we still need to calculate the right sum, right? So since we are initialize this left sum to 0, and we are doing the math here, so that math calculation should be done after here. I mean, like, first we need to compare instead of doing the accumulation or math stuff, right, for the left sum. And how about the right sum? So as I said earlier, so basically we can get the right sum from the total, I mean from the nums.total here, and we need to subtract it with the left sum, but including that current iterated index, which is the number, right? So of course we don't have this total, so let's get the helper. I guess we can quickly create that extension of the array where the element is an integer, and you can use the var get here, which is the total returns an integer. And I believe you can do the for loop for every single number in self, right? And let's accumulate that. So the sum is number is gonna sums to the sum. We need to return the sum. Oops. And we need to create the sum variable over there. And I believe that should do it. So let's make it private here. Cool. And I believe that should do it. And let's try to run the test and let's see if we got the correct result. Cool, there you are. So that's how we can solve this problem. I mean, like, migrating from the old implementation to the new implementation. But here we are basically still doing the O of n square. Why? Because we are doing this loop once, and then we are keep calling this every single loop, which it says that it is stated that we need the total for this, and it is basically another loop. So why don't we like try to move that in here, so that we can call it once only, right? This total is calculated here, so it is not going to recalculate it over time. So this is basically migrated from the O of n square to the O of n time. So let's move this around to bottom, since seems like we don't use this anymore. Can delete that. Let's move this to bottom and let's run the test again. Let's see if we still have green test. Good, very good. So I think that's how we can solve it. That's the step how we can change the implementation without changing the behavior. So this is the one of the power of TDD as well, because we just change the implementation without changing the behavior, right? So the test is guaranteeing us so that we can refactor without altering any behavior, but still we have pretty good tests and solid tests to go. So yeah, that's one of the important. So let's commit here. So okay, that's how we can optimize this pivot index algorithm from the O of n square to O of n only, and while maintaining this same behavior using test-driven development, because when we are trying to change the implementation, we can still guaranteeing that the test is still running as before, since we have a very solid foundation of tests here. So it's like pretty much safe to do the refactoring stuff because we have the good solid tests around that. So let's try to copy and paste and let's see if it is still working or not. So let's paste around that and let's run and submit. Cool, we are passing the test and submit. Alright, so that's another improvement, and see you in the next video. Bye.